We're live. It is your morning motivation show. I'm back in the morning. It's early enough to be morning. It's not late in the afternoon. Today we're going to talk about the thumbnail that I put up. That is a Holley high ram with two, I think that they were both 950s. They might have been 750s. At any rate, there were more than enough carburetor for the thing that we were doing. But this is way back when I did our DESTROKE LS3 with a 4/8 crank, basically, and a custom rod, and then a kind of a standard compression height piston, I think. We had pistons done for it as well. But what I wanted to do was we wanted to run a big bore and a short stroke because, you know, everyone knows that you can run lots of RPM like that. The reality is you can run the RPM with other strokes too. But I hadn't ever built one of these, so I built one way back. And the interesting thing about it, we've covered it a couple of times, but the interesting thing about it, what a lot of guys don't know, is I ran both, and I'm going to do a full video on this today, so you guys will be able to watch that. But I ran this combination both with ported cathedral port heads and ported rec port heads. So it's one of the few times that I ran the same combination with not just, because I've done the LY6 6-liter, we ran the stock rec port heads, and then I ran ported cathedral ports and also stock cathedral ports, but never ported rec port heads. So I don't remember another instance where I ran compared ported rec port heads to ported cathedral port heads, both of them that were good heads. And in this case, this thing made over 600 horsepower, so it was utilizing at least a good portion of the available head flow. And to see what happened, I was very excited about this because we'd run this combination. The idea was to run more than 8,000 RPM with hydraulic roller setup, which we had done, and you know, lots of people had done back then too. But we wanted to just show that and demonstrate it, and I hadn't ever done it, so I wanted to do it officially. We know that it could be done, obviously. In fact, guys have run way more than that. So we wanted to see if it could be done. So I put together a combination, and it was we had custom cams done both by the guys at Comp and Brian Tooley Racing, which varied dramatically in their specs and the camshafts. Both of them went over 8,000. Both of them made good power. Both of them, they made different power curves because one of them was bigger and one of them was smaller, which is what we would kind of expect. But we ran Airflow Research 230, I think, cathedral port heads on this thing. Let me get the specs here. So we ran, it was an LS3 aluminum block. We ran a 4/8 crank. We had 6/300 Lanati forged rods in it, custom pistons with small domes on them. We ran Airflow Research LSX 230 heads with 62cc chambers. We ran, and this thing had a Moroso oil pan, so it was pretty good wind tray and stuff. We ran a Holley high ram with dual 950s, and then an ATI damper, and then we ran a comp cam and the BTR cam, and then run with the Airflow Research heads. This thing made over 600, and then we also ran it with a set of Trick Flow CNC rec port heads. Let's see, I think that they were, let's see what, the TFS 255 rec port heads. And in both cases, we ran the high ram with carburation. And the reason that I did that is because we wanted to show good power gains. And the high ram run with carburetors on it actually made more power than the high ram run with EFI. Run with either we only ran port injection, but we ran it with 4150 throttle bodies, and then also with a single 102 millimeter inlet. And the dual 4150s flow a little bit more, but with carburation and fuel cooling the charge air in the high ram, it seemed to make the best power. And with the carburetors, we could tune pretty well, although I didn't run 802s in this to find out how the distribution was on this combination. Probably would have been a good idea, because then we could have done maybe some staggered corner jetting and stuff to try to improve it a little bit. But we just tuned it so that it made the best power. And we ran like I said, we ran a comparison between two different camshafts, and then we ran the two different cylinder heads. The interesting thing is that the cathedral port heads made more power, but they had a smaller chamber too. So they had a 62cc chamber versus a 69 or 70 for the trick flow rec port head. So the rec port heads are naturally going to complain about that and say, oh, well, if you mill them and run them at the same chamber size, but that's not how they came. I just ran both heads the way that they came. We just kind of wanted to see, because I know that the ported trick flow rec port heads flowed a bit more than the Airflow Research 230 heads did. And obviously different shape, different port volume, different valve sizes, all of that stuff was different. So it's interesting to see that comparison. But the thing is, how do you denote this combination? Is it a LS3 that you destroked with the 4.8 crank, or is it a 4.8 that you big bore blocked the thing? So it is a bigger 4.8 or a smaller LS3? Because this thing had a 4170 bore, or a 4070 bore, I should say. And I think I put my stuff in wrong here on my Wallace Racing calculator here. Wallace Racing displacement calculator. So you go to wallaceracing.com, put in our bore, which was 4.070, and our stroke 4.4264.8. So 443 cubic inches for this combination with a 4.0, because we bored it 5 thousandths over, so it wasn't a 4.065, it was a 4.070, and I think that the stroke on this 4.8 liter. Let's see here. .267. I got 3.264. Yeah, 443, 444 cubic inches. So that come on. Nice. Way to go, camera. There we go. So 443 or 4 cubic inches, and big bore, short stroke, 8,000 RPM, not a bajillion RPM, but some. And this thing made over 600 horsepower, so it did well. So you utilized both of these cylinder heads. So how you classify this, I think says a lot about you personally. And looking at because a lot of guys they get in they get their mindset such that they want to de-stroke the motor so it runs lots of RPM. Quite honestly, you don't have to do that. That doesn't really go together. You could run a 4-inch stroke. You could run the 3.622, the stock stroke, and you can still run this RPM. I know people want to talk about, let's talk about mean piston speed, and let's talk about rod ratio, and let's talk about all this stuff. But the reality is you can do that with all sorts of different stroke lengths and all sorts of different displacements. There's no arguing the fact that if we would have just left this at an LS3 displacement, it would have made more power. Even making it smaller doesn't make more power. So going down in displacement, bad for power. Going up in displacement is good for power. So if you're looking at this as a 4.8 and you make it a big bore 4.8, all sorts of good things happen. You have more displacement, so that's going to be more power. You also have a bigger bore size, which helps cylinder head flow, because the 3.780 bore not going to work with a rec port head, not going to work with our Airflow Research 230 head, because it has a much bigger chamber, and not just bigger in volume, but bigger in diameter, in inside diameter, let's say. So the bigger bore helps breathing. So you can make more power with, and I'm not going to say with a bigger bore, you can make more power with more displacement, and the bigger bore can help airflow. So if you're going to do that, and most race motors do that, if they're going to make a given displacement, they usually concentrate on the bore size, not because short strokes make more power, but because bigger bore sizes adds airflow, and you can improve upon things that way. This was interesting because not only did we do this high RPM hydraulic roller deal, which is kind of the reason behind all this, but also because we ran this LS with the high ram with carburetors on it, which was a little bit unique because we ran it with a cathedral port and a rec port head, different versions of these heads, and also because we ran different camshafts on them. So it was interesting. And it was a good exercise. It's very, very popular. Lots of people like the video where we did this DESTROKE deal, and they liked it. So it made, it made good power. Made over 600 horsepower. Went over 8,000 RPM. Did it with a hydraulic roller. So technically, was a big success. I think that there are other camshafts that we could have had. We could have made power, and this is one of the things when I post the video today that people will complain about. There'll be two kinds of complaints in the comments, so please make the comments. One will be that the compression was different between a rec port head and a cathedral port head, and then the other will be we used my wrong cam t-shirt. You didn't have the right cam. It wasn't optimized for either the cathedral port head or the rec port head or whatever. And so those will be the complaints, but that's okay. We want them to be there because more complaints obviously are always better. So I'm going to go right off to live chat and see what people are up to, because I think I could go back all the way to the beginning. We need to get a poll up here. Okay, is a D-stroke motor better for high RPM? We're not even going to say D-stroke. Let's make this even easier. Short stroke motor better for high RPM. Okay, so let's see what you guys got going on. You spelled big boost wrong. Exactly. And the interesting thing, and I forgot about that as a side note, we took this short stroke LS3 or big bore 4.8, and I'm pretty sure it was with the rec port heads. We ran it with boost too. So we ran, and that's another common myth that people think, oh yeah, the short stroke motor, that's going to work good with boost though. Every motor works good with boost. Whatever you start with is going to determine what you end up with. And because of its stroke, it's not going to like boost better than having the longer stroke. Either one of those motors will respond well to boost, and they'll respond in the same manner. So if we start off with 600 and we add 1 bar of boost, we should end up at 1200. That's what will happen. And it'll happen with whether that has a short stroke or a long stroke. Whatever we made our 600 horsepower with, it's going to do the same thing. And because that's how it works. That's how boost works. I'm in the building just listening to the podcast, about to go on the road again. You're going to pick up fertilizer, right? Camaro LT1. I'm going to get those heads done. I think the guys are wanting to port a little bigger valves in the 3800 head. I might need some help with your celebrity status. A bigger valve, I think most people that are porting those heads and trying to get the last bit out of them are putting bigger valves in them. I would be more concerned about putting a bigger intake valve in there than an exhaust valve, but both could help. Since GM came out with that high revving 5.5 liter, now everyone has jumped on the bandwagon. Definitely a good direction to de-stroke it. Or high RPM it. I think honestly for OEM applications, as much as I like Ferraris and those kinds of motors, a naturally aspirated motor that has a very high specific output, I don't think I would choose that over any sort of factory boosted application. Only because when you get a boosted application, if you look at stuff historically, like look at an 03 Cobra motor, look at anything that had like the Lightning stuff, in the Ford stuff. Look at the LS9 motors. Look at the LT4 motors. Anything that had a factory, the Hemi stuff with the Hellcat and those. Look at anything that had a factory supercharger or a factory turbo on it. The reason that I like those, if I was buying an OEM one, if I could ever consider affording a new car, which is probably not likely, but even if you bought an older one, which I have a Dodge Omni, so you're thinking about turbo stuff, factory turbo stuff is good, or factory blower stuff is good, because they've built in strength into this, and like we've seen with the NA motors, there's a lot more strength than the factory put these in so that these would last a long time. And they made them stout enough that they're not going to have warranty things, which means we can turn the boost up on these things and make more power. And with the factory forced induction stuff, you know, you can change pulleys on a blower thing. You can put controllers or whatever for the boost on the factory stuff. And I like that. It's so much easier to make more power with those. If you have a real high specific output NA motor, it's actually harder to get more power from that. So if you take a high specific output like S2000 Honda, one of the Ferrari motors that have a very high specific output, 355, 360, 430, 455, whatever these things are, 458, then it gets harder to gain power because they did a pretty good job getting a fairly high specific output. So you're not going to just go get a truck Norris cam and put it in your Ferrari. That's just not, you'd have to have 4 of them, but that's not going to do it. But if there were boost on the factory one, it's pretty easy to get additional gains. Found a good valve spring kit for my ported trick flow twisted wedge head, LS dual springs, titanium retainers, or tool steel retainers. What would you choose? Either one of those will work. You're never going to be running enough RPM that titanium retainers are going to be necessary on a 3800 if it's boosted. So I wouldn't worry about that. The tool steel stuff is fine. In fact, there's testing that Brian showed me that the tool steel stuff probably has worked better than the titanium stuff on some applications. How much would a twin cylinder Mako 700 make? Think it could beat a nitrous high boosted being 1400 cc and probably any LS. I don't know what a Mako 700 is. Yeah, JPL. We used steel retainers on the stuff that I ran before. What do you think about a 388 small block Chevy on methanol with an F1X and Airflow Research 225s? Is capable of 15 to 20 pounds is a big difference in boost. But yes, a small block Chevy, I don't know what block you have, and that's the thing that I would ask, and are the internals forged and that kind of stuff. But the F1X will certainly support that boost level. And if you have a good camshaft in it, the 388 worries me a little bit about whatever bore size you chose, unless you have. Do you have a 4125 bore block? If you don't, if you have a 4-inch bore block and you've gone out to 388, I don't think I would go that big, especially if you have boost. Would it be foolish to use an L-block cross ram on a D-stroke LS3? The cross ram on a D-stroke one probably is not going to want. It's not going to want to run 8,000 RPM because it has pretty long runners, and so it's going to be done making power way before that. So it's probably not a good combination. Richard, how fast could you spin the old 4.6 liter small block? I don't recognize that metric designation. Is that a 283? Yeah, Turbo Sentra, if you put a bigger exhaust cam in it, it should help it make power. There was a turbo V8 Lotus. The Esprits later came with V8 turbos. Was there a factory V8 turbo besides the Pontiac? Yeah, lots of 4-cylinder stuff. What is the theory behind boosting LS versus small block Chevy? There is no theory. They both like boost. Overbuilt. Richard, to me, an engine like that peaky be great in a car with a 6-speed manual trans. Why would people want to destroke a K24 down to 2.2 liter? I don't know. I wouldn't do that. The K24 has plenty of RPM potential. We've run RPM, and it makes lots of power, and it makes torque. So for any kind of street motor, I think I would pick the bigger one. Richard, any advice on getting a 6-liter rear main sealed? To already replace one and it's still leaking? I'm told that the factory GM rear main seals are the ones to use. In fact, I had a guy that replaced mine in my truck, so that while I was doing dyno testing at West-Tech, I just gave him the truck and said, here, you replace this, and paid him to do that. He said, I will do this and I will warranty it that it won't leak again, only if you use the factory GM one. If you use the Felpro one, he said, I won't warranty it. I said, okay, if there's a difference between those, and you'll do it. That's what he told me, so that's the information I'm giving you. Just a question: if a 327 is a 4-inch bore and a 3250 stroke, how is a 4070 by 362 400 plus? It's not 400 plus. A 4070 bore is 344 inches. Let's see. Richard, can I request you set up notifications on your channel? I do have notifications. Do you have a 5-minute warning of going live? I'm not sure how to do that. I missed the first 12 minutes again. I'm not sure how to do that. I can look and see. Going Breck Racing, 425 bore, 36250 stroke dart block. That's it. I've never heard of that stroke length on a. I mean, they make all kinds of different ones, but don't ever remember seeing that for a small block Chevy. Josh, decapping injectors. Your question: why do people decap the injectors? Because it will make the flow rates go up dramatically. The problem is that you have to do a whole bunch of them to get before they're decapped. Usually the flow rate's pretty consistent. Once you decap them, the flow rate is not consistent anymore. So you have to do a bunch of them to make sure that you get a match set. Shenanigans. Missed the beginning of this. Anyone going fast and keeping a stock bottom mount LS alive will constantly run over 8,000. So they're going to run more RPM to keep the motor alive. The new exhaust cam has 85 thousandths clearance before it hits the bucket housing, so probably max lift. Hot mess to 283. A 283 is not going to rev any better than a 327 or a 350 or any of these other ones. In fact, it has a very small bore. Any specific years and vehicle types to look for when going to junkyard for LS motors? Almost all of the 2000 and up cars and trucks, and earlier in cars, although we don't see many cars. Lots of trucks and SUVs from 2000 on up are going to have, some of them have big blocks, but those should all have LS motors in them. And people like Gen 4 stuff because it's a little bit stronger. But quite honestly, if you're putting together an NA motor or even a boosted motor of less than 1,000 horsepower, the Gen 3 stuff works fine. Richard, you can schedule lives through your channel dashboard. I can't schedule live feeds because I don't know what time I'm going to be on. I only know when I'm going to be on right when I get on. Fascist, that's a good idea. Start the live stream 10 minutes before you start talking. Just sit Milo in front of the camera. Anyone know the injector flow rate on L59? Yeah, if you go to on all cylinders, OAC for Summit, they'll tell you all the specs on the different LS designations. Is it necessary to get a high flow fuel pump for a 500 horsepower motor, 2011 5.3 liter NA Suburban? Does anybody know what the flow rate of the factory fuel pump is? How much it will support? On an NA motor, it's going to be a little bit easier, and especially if you have, well, it's not going to matter because you're going to have 58 psi. One way that you could improve the flow rate of the pump is if you have a bigger injector, if you're able to tune it, which on a 500 horsepower motor, you're going to have bigger injectors, and you run lower fuel pressure. So if you bring the system pressure is 58 psi on most LS applications, if you bring that down to 43 and put a bigger injector in it, the flow rate of the pump will go up. Mr. Richard, can my 83 Z28 be tuned? As they say, it's just a simple carb ECM. Yeah, I don't know what the factory's probably controlling the timing, and if that has a feedback carburetor, it's also controlling the feedback. But the most of the air fuel tuning is going to have to probably be done by the carburetor, and then if you're going to put a cam and everything in, all that's pretty normal. If a 351M and a 351 Cleveland have the same cam and compression, would they have to have the same intake and the same cylinder head? The deck height and the bearing size, I don't think is going to have hardly any effect on power. I think what will change it is the deck height will change the intake manifold, so it might change the runner length in the intake manifold. So there's no way to make those the same. Do you have build sheets for some of your LS motors? But no, but the videos and the discussion here, we can tell you everything that we had in the motor. Yeah, that's I only know what I'm going to be on right before I go on. Dan, thank you very much. And if you have a question about a specific motor, I can tell you what it had in it. Aside from abuse, what does a steady state single RPM pull? We can load it at 15 pounds, but the thing is, you don't ever see that in the real world. Nobody ever has a stationary load at a given, like at full throttle, at full boost like that. That's never duplicated anywhere. And there's no pull at a steady state load. You just load it. But I wouldn't ever do that to a motor. I wouldn't let it sit there for very long. We do that stationary load, and then the dyno pulls it to some starting point, whatever our desired start RPM is, and then we release it. I don't keep it there very long, especially not under boost. What Ford V8 is the best for high RPM builds? Probably a Coyote or some sort of modular thing. The deck height on the M motors is going to change the intake manifold. It also changes the rod length, so you got better rod ratio, right? So that should make more power. Because all about that rod ratio. So how's our pull doing? 66%. Let's see here. Oh, wow. We did a big charge there, huh? Interesting. Okay, 66% are saying yes, this 6 short stroke is better for high RPM. Most fuel pumps have flow. Have you actually flow tested the fuel pumps? So do you know what the flow numbers are on the fuel pumps? I'm not building one at a complete 283 a few weeks ago and sold it to a co-worker that was restoring a 68 Impala and needed numbers matching engine from that year. Now I'm kicking myself. Have you seen push connect fittings leak boost for reference to the gate? That would be possible. I don't normally use those for wastegate reference. Who is ready for the new NHRA Pro Stock replacement Factory X? So what is that? I don't know what that is. Factory X. Sounds like a superhero team. Hot mess. I scrolled back. I was told you could spin the 283s without blowing it up because of the thicker casting, less core shift, and higher horsepower and load levels, kind of like a 4.8 versus a 6.0. There's no difference between a 4.8 and a 6.0 in terms of RPM. The 4.8 needs to rev higher to make its peak power with all the stock stuff because it's smaller, but it doesn't like to do that because it has a short stroke. That's it's just doing that because it's smaller. A 6.0, as we've already demonstrated, has plenty of strength. I mean, given by what we did with the Big Bang stuff, because that was a common misconception. Oh, you don't have the same head gasket sealing on a 6.0 as you do on a 5.3 or a 4.8 because you have greater distance, sealing distance between the cylinders because the bore size is smaller, yada yada yada. But that's not really where that's true. But the thing is do you get to the point where that's the thing that's the weak link? Is it the sealing thickness between the cylinders that creates the problem, or is the deck thickness of the head, does that lift off and you lift the head and then blow head gaskets? And so it's not the amount of thickness you have between the cylinders. Daniel, what are the dyno fees at Westech? You got to contact them and tell them what you have and stuff, and they can give you an idea. What is your opinion on the Victor Jr. intake with an elbow on a twin turbo stock bottom end 5.3? What do you mean? That sounds like a thoughts question. What is it you're trying to do? Lots of people run it, but it's not better or worse than anything else. You shouldn't be worried about the elbow. The single plane intake manifold is designed to make power in a given RPM range. What I don't like about a single plane intake manifold is, in all of the testing that I've run, if you look at the intake manifold test that I've done, since that's going to be a cathedral port, since it's a 5.3, the Victor Jr. never did well in power compared to the other stuff. Almost all of the EFI manifolds were better than the Victor Jr. So in my opinion, given 7,000 RPM or less running speed, I wouldn't choose that intake manifold for a twin turbo small block. I'd choose a fast because it makes a lot more average power. Or a high ram. The other thing I don't like about single plane intake manifolds is that it has 4 long and 4 short runners, so you're producing different power in different cylinders during the RPM range. That being said, you can make lots and lots of power. You can make 1,000 horsepower or 1,500 horsepower blowing through that. I would just, depending on the RPM range, I probably would pick something different. Why does a 4.8 or 5.3 make so much more power than a 305? They have close to the same bore size. They make the LS makes more power because there's a way better cylinder head than the 305 does. It also has maybe better camshafts. It has roller camshafts unless you pick a roller 305. It has a way better intake manifold. But intake and cylinder head, it also has a windage tray, a factory windage tray. It's just better. Let's see. How did the whole Westing thing come about? I started testing there long ago because I had done that stuff before Westech, not on the engine dyno. I'd done most of it on the chassis dyno before that, but I've always been interested in demonstrating to people things that actually work. What does it actually do? Because when I was writing for the magazines, and we would do before, they were just doing like, oh, let's put this exhaust on this Camaro. Okay, that's great. Oh, well, it says it adds 15 horsepower. I'm like, yeah, but how do you know that it does that? Well, it says it. I'm like, yeah, but we're supposed to be the people that are telling them that it does that. I'm not going to tell somebody in a story that it does that if it doesn't do that, because that's not accurate. It also does a disservice to them if it doesn't do that. I could tell them, look, it sounds really great. It's loud. It sounds throaty, whatever. I can say that, but I can't tell them that it adds 15 horsepower if we don't know that. Let's at least do back in the day, a Varicom or acceleration, or let's put it on a chassis dyno and find out if it actually does that. And they're like, yeah, that's a lot of work. I'm like, I know, but that's our job. We should be doing that. And so the Westech thing was just an outgrowth of that to be able to come and do stories and do actual testing, which was, as soon as I did my first engine dyno test, I'm like, oh yeah, I'm all in on this. How does the flow rates of an OEM truck intake manifold 5.3 to a TB compared to a TBS? Is it worth the money to replace? Lucky for you, I have lots and lots of truck versus Trailblazer SS intake videos up, and you can see how much they gain. You'll gain more going to a Trailblazer SS. The wilder the combination is, or the bigger the combination is, the more you'll gain with that Trailblazer SS. So if you have a stock 5.3 and you take off your truck manifold and put a Trailblazer SS, you're not going to gain as much. If you have a cammed 5.3, you're going to gain more. But I have lots of videos up there to show you how much it's worth. And then you can see what the power gain is, and then only you can decide if that amount of gain is worth that amount of power. Richard, speaking in reference to boost as well, 283, since it's almost all we do anymore. Thicker the material between the seals also helps it seal. Yeah, but again, while that's true, just like it's true that a bigger throttle body flows more than a smaller one, if the smaller throttle body that you're using on your motor isn't restricting it, the bigger throttle body isn't any gain. So when we're talking about that and people are making that comparison, they're asking the wrong question. The sealing surface, the thickness between the cylinders, if one is thicker than the other, that might be true, but that's not the real question you're asking. The real question you should be asking when you're wanting to run boost on there is, does that become a problem? Is that the limitation, or does something else happen? Do we break a connecting rod? Do we lift the head? Is there another problem that happens in our line of problems before that happens? That might be all the way at the top. That might be the very last thing that lets go, and all these other things are going to let go before that. So that's all but irrelevant in our discussion. How are guys lifting heads off the block because block's failing midway? Is it from the bolt stretching, heads warping? It's usually from the head warping because the deck thickness isn't strong enough on the factory heads. We know that because when they go to an aftermarket head, it doesn't happen anymore. Yeah, it's 344 inches, right? Oh, I put in 426. It should be 326. 440 inches. That's right. So I did make a mistake there. The magic with a short stroke long rod is you can run higher static compression and higher cylinder pressures on pump gas. So you think that the rod ratio is going to change the detonation threshold? Piecing together a 5.3 with twin GT3582s. The cam I have is very close in specs to a jam cam. I don't know what that is. This is a budget build. I have a Victor Jr. I'm not looking to set the world on fire. If you have twin GT35s and you have that intake manifold and you have stock heads and some sort of whatever kind of camshaft in it, as long as it's not too big. I'm hoping that the cam isn't really big, because if it is, you're not going to be happy with it. You should run a small cam on that, and then it will work fine. My dad's building a D-stroke 632. That's good. Cam, 800 horsepower would be really easy with those turbos, with almost any kind of combination. I like the lift test on the Truck Norris versus the NSR. I don't know how the other cams would respond to changes in lift. I don't know if I've seen an exact duplicate of another cam that just has less lift. John, I'm a little late to the party. In most common configurations, valve train is more the limitation than stroke and higher RPM application. That's true. That's what I was talking about. In the sequence of problems that you have to cure some kind of problem, if it's RPM, all the valve train stuff is way before any stroke thing. How much will cam timing affect the engine? The new exhaust cam pin is not the same as the OEM. It will be half a tooth different. You'll want to adjust cam timing. And if you're trying to be a record breaker or whatever, all of that stuff has to be right. Two 3242 at 50. You don't need a cam anywhere near that big in a 5.3 to make 800 horsepower. You could go down 20 degrees in duration. Like, I'd like to see a Truck Norris cam in that thing, but it will work. It's just going to be really soft with a single plane intake manifold and that big a camshaft on a 5.3 with those twin GT3582s. It's not going to be very responsive. I just received a Truck Norris cam. Truck Norris, I don't know what a Truck Norris Stage 2 is. I thought a Truck Norris was just a Truck Norris. What do you recommend for tuning? You can do it if you have I don't know what application this is, but you can do everything that you need to do with a stock ECU, or you could do it with an aftermarket one. Lucas, engine masters related, how much attention was given to optimizing each cylinder? Say one was making 60 horsepower, another was making 55, another was making 65. A V8, 500 horsepower V8, for example. I don't know how you determine the actual power output of each cylinder. So how are you doing that? One thing we've looked at is, and maybe you were talking about my discussion on the intake manifold, but if you have, let's say you have 4-inch runners and 6-inch runners it's probably going to be, the difference is probably going to be more than that. But if you have two 4-inch runners and two 6-inch runners, they're going to want to make peak power at different engine speeds. And while you're going up in RPM, they're going to be making different power. They're also going to be having different air fuel because of the draw from the carburetor is going to be different in those cylinders. And also, it's also the distribution is going to be weird just because of what's happening in the manifold, irrespective of what's happening because of the change in reflected wave from the runner length. What you can do, and what I did do, is I have a video up where we put port injection on this, ran a carburetor, ran it with port injection, ran it with batch fire, ran it with sequential, and then did individual cylinder trimming so that we had the same air fuel in all cylinders at all RPM. As it turned out, it didn't make a big difference in power because as we've seen on these LS motors, whether I run it at 13.0 or 1250 or 12.3 or whatever, it doesn't make a big difference in power. So it's not real responsive to changes in air fuel anyway. So if you have some that are a little bit lean, a little bit rich or whatever, as long as they're safe and don't hurt themselves, the power production is actually very similar, or their receptiveness to air fuel changes. But the difference in runner length will definitely make different power in those runners, in those cylinders at different engine speeds. I don't know how you determine that though. But the way to cure it is to have all the runner lengths the same, like you do on a high ram, like you do on a fast, or some of these other manifolds. The longer rod results in less cylinder wear. I know we want that to happen, and I know that when you're looking at it as a overly exaggerated example, but does that really happen? Matt, it's not 443 inches, it's 340 inches. I just put in a 4 instead of a 3 when I was doing my compression calculator. 340 inches, 4070 by 3627 is what I have in there. 8 cylinders, 340 cubic inches, 5.6 liters. The piston speed is going to be the same. And here's what people get incorrect about talking about piston speed. Most people are calculating, are you calculating average or mean piston speed? Are you calculating piston speed at different points? Because the acceleration rates are going to be different with different rod lengths. But what will it be as an average? What will it be at the median point? There's all sorts of, you could get real technical on this, and if you wanted to, but you could calculate it for the first 5 degrees or 2 degrees or 1 degree, or first 20 degrees or the bottom 20 degrees. You need to look at all of that to see. And if you were really getting after it, and you could look at all that stuff. But again, given what we've done in changes in rod length and stuff, and not seeing anything on the dyno, even though you have all of that, and even though we've changed that, and even though those things have changed, it's like our discussion with the difference in thickness between the bores. Yes, we've changed that, and you would think common sense would dictate that there would be more structure there and there would be more sealing. But again, is that the problem? Is that the thing that's going to change something? Cam, if it's a drag car and you have a 5,000 stall with a converter, then you'll be fine. Because you'll be able to put it on a 2-step, and you'll have that much stall speed. You'll already be making power. That'll be fine. So let's see how our poll is doing while everyone's arguing about silly things. The short stroke motor better for high RPM. 72% are saying yes. Yeah, Cam, if you've already got what you need. If you a 5,000 stall is a lot, so that's good, and it's a glide, and so you're all set up if it's a drag race car. Remember, this is the big things versus versus the little things that make a difference. I am interested though in the comment that somebody made about the dwell time versus detonation threshold. That would be interesting to see if that has an effect, or if that is how much of an effect it has. That would be an OEM level of test regiment to make that happen. William, stock head, stock Ellis block. Is there a rule of guess when O-ring the head is viable? You don't need to do that if you have a stock head. The stock head's going to lift before you O-ring it. You need a better head before you have to worry about that. You will not, like I said, we're at 1,500 horsepower. What power level are you trying to do? 1,500 horsepower with just head studs and MLS gaskets. And on that one, I think that one actually had I think that those reported 317 heads on that. That's even a stock head. So it's not there. And then if we have a better head on there, like an aftermarket head that has more deck thickness, it would go beyond that. Can smaller cams rev faster before meeting valve train instability? What do you mean rev faster? Like a free rev? Because that's what faster to me means. Or is that quicker? Or are you talking about more high RPM? If you're talking about just RPM potential, you have to have the camshaft has to be designed with stability in mind. It doesn't necessarily have to be smaller or milder. It has to actually be combined with spring frequency and obviously to some extent rate. But there's a lot that goes into making the thing be stable at high RPM. Hot mess. I tend to agree with the dwell time and the detonation thing. I just was curious if there was something there, because detonation can still happen at TDC or even slightly after TDC, because localized hotspots can do that. I just don't know if the time at TDC would affect that. Like I said, that's a whole different microscopic level of inspection for something like that, and it would be hard to do in anything but a OEM level environment. Again, fascist, I don't know what you mean by is it easier to rev a small cam? I don't know what you mean by that. What's our poll doing? 73% are saying yes, short stroke. Need a spintron for valve stability test, at least what we had in college. Yeah, a spintron's a really good place to develop cam and spring and all of these things. Not just that, but the cam and the spring, the lifter, the push rod, the rocker, the stands, all of that stuff affects the rocker ratio. All of these things affect the weight of the rocker, where the weight is positioned on the rocker. There's a lot of things that affect high RPM stability. What's the best NA cam for 408 LS top end? I don't know. The 408 and the 11:1 only tell you a very, very small amount of what you need. I don't know what RPM you want to run. I don't know what cam. I don't know what cylinder heads you have on there. I don't know what intake manifold you have on there. I don't know any of that stuff. I don't know what you're trying to do with it. Is it a daily driver? Do you have a stock converter in it? Is it a drag race application? There's an awful lot of stuff that goes in there, but I do have 408 tests up on the channel where we ran 3 or 4 or 5 different cams in, so you can kind of get an idea from there. A smaller cam has to rev higher before float. That's not true. We need to, we need to define what you mean. What is your definition of smaller and larger? And then what is higher and lower in RPM? We've had small cams experience valve float way earlier than bigger cams, but it depends on what your definition of that is. My 4-inch stroke small block has no problem hitting 8,000 RPM. Yeah, the stroke isn't normally a limiting factor. The valve train stuff that we're discussing is way harder. Poll question is somewhat open-ended because of, from my understanding, board stroke ratio is what matters. It's not. What matters is valve train stability. We can run high RPM stuff with, like for instance, take a stock 4.8. It does not have a favorable board stroke ratio, but that doesn't matter. We can still run a 4.8 to 8,000 RPM. If we have the right cam and valve train in it, it will easily do that, even with the longer stroke. Or if let's take a 5.3 as an example instead of a 4.8. A 4.8 and a 5.3, we could both run to 8,000 RPM. A dramatic difference in board stroke ratio. Richard, what's a realistic max wheel horsepower be for a 462 valve? Are you talking about a boosted one or an NA one, or what are you trying to do? We've made 462 valve NA versions that make near 400 horsepower at the flywheel. So that should be 300 at the wheels, I think. Guys probably have done way more than that now, but I don't know what they're doing with like the trick flow heads and like a Victor Jr. intake manifold. I don't know what kind of RPM you want to run, but 400 wheel horsepower is really easy with boost though. I just worry about throwing a rod more than valve train problems. All of that is obviously a consideration too, but that doesn't have anything to do with stroke. That has a much more to do with like the quality of the stuff that you pick. Cam, with 243 heads work better than 862 heads on a cam 5.3 boost? No, they won't. You're not at the limit of the head flow, especially with boost. With boost, the cylinder head becomes less of an issue, unless you're trying to run lots and lots of power. If you're trying to make 800 horsepower, you could close your eyes and pick any factory LS head and it would work just fine. The heads that you have on there, whatever heads you have on there are the heads that you should use. Does Brian use a Spintron when he's developing his valve train and cams? Yes, he has a Spintron at his place. And it's been a huge jump in quality and development because of that. Derek, is yours a 462 valve? It's stock bottom end, but what is the danger zone? About 500 wheel horsepower, and I'm concerned about the stock bottom end. If this is a 462 valve, what I would be worried about is not the stock bottom end. We've gone way over 600 horsepower flywheel on stuff, so that's where you are. I would be worried about just make sure that you have ring gap in it, and make sure that you have good gas in it, and that the tune is right, and that you have an intercooler. Aaron, the cheapest way to do the Gen 6 is to keep the stock heads on it, maybe do a little porting on them, set up the valve train so you can put a camshaft in it. For a daily driver, I would not put a big camshaft in it, like that 276 cam that we put in it. It is a pretty good combination of power. That made like 425, so it went up from 375 to 425 with that camshaft in it. If you're keeping it fuel injected, you might do a little bit of, well, I don't think you can even port the intake manifold really. Porting on the head would help. Bulwark and stuff on the head would help. And then also you could change the compression by milling the head. Would a 234, 242 be good for a 408? Yeah, that's. I think that if you look at the cams I used in the video, we put a 239 cam in it, and it made good power with that. But it's not something I would use. Not the cam I would pick for a daily driver. I'd pick something smaller, but that cam will work. Richard, how much camshaft do you think is too much camshaft? I recently bought a Comp 268H and wondering if it would be too much for my stock 302 Cleveland. This is it a Cleveland cam or is that a Windsor cam for that? I don't know what block that is. Is it this? If that's in Australia and they made, I think that they made 302 Clevelands, right? If you can tell me what is that like a 224 F50 camshaft? That actually should be fine. Let's see. $268H. Well, it doesn't really matter whether it's a Windsor or a $268H. Is that a high energy one? That's 218 if that's what it is. So let me know what the specs are, but that'll be fine. I had a bigger cam than that in my 302 5-liter. I had a 274 in it and drove it around every day. Come on. Stupid camera. Freaking out. Let's see. Ricky, are you asking which engine is superior? There is no such thing. One engine doesn't have to be better than the other. They both can be excellent. Are you zooming? Are you zooming, camera? Come on. I'm trying to trick my camera. Let's see. Are there any aftermarket Ford modular heads? There are aftermarket Ford 2V heads, but not for aftermarket 4V heads that I know of. I'm using water meth intercooled 93 octane. It's got full supporting mods, rev limiter, 6,000 RPM. You heard RPM kills them. Yeah, we've run more than that, but yeah, all of that should work fine. It would like it a lot if you ran E85. That cam will be fine for your 302. And which is it an extreme energy cam? Why are gas-powered rings a new wave in the last 5 years? Gas-powered rings have been around a really long time. I don't think that that's a new thing. Your head's too small for the cameras to focus on. I did. That's why I did the big head thing. Oh, the mic. That's right. You guys should have reminded me. My mic is not close enough. Rod, did you by chance catch my question about the Terminator X ECU? I did not. I could scroll back and see if I could find it, though. Scrolling. Rod, I had Steven-ish tune my big block Chevy with a Terminator X. My question to you, will the Terminator X adjust once in a car with my exhaust system? Will I still have the best state of tune? I don't know what you mean by will it adjust with the exhaust system? Did you tune it on the engine dyno? And if you tune it on the engine dyno, the tune's going to be different in the car. Definitely. Richard, from your comments, you don't care how an engine sounds after a cam swap. I do, but I don't. But that's not why I buy the camshaft. A lot of people buy the camshaft just for that. They want the cammy sound. They want the chop. That's what they care about. They could care less about how much power it makes. But I lean more toward the power that it makes, and then the cam is the sound is an afterthought. Daryl, I don't know what your comment is about there. I didn't see something that happened before that. So I don't understand what you're talking about in terms of fuel mileage. Will a .82 AR make a big difference from a 70 AR on a GT 3582? It'll make it more laggy if you want that. But I wouldn't make a change in the AR until you have data and you've taken a look to see what the boost pressure versus back pressure relationship are. At 800 horsepower with those turbos, you should still be in the sweet spot of those. Online calculators state that you need 347 cubic inches to make 500 horsepower. That's not anywhere near accurate. we easily exceeded 500 horsepower with 5.3 liter LS stuff all the time with just heads, cam, and intake manifold. And it's possible to make 500 horsepower with out of 5 liter motors or 4 liter motors. So all of that is easily possible. And you can do it. You can probably do it with a 2 liter, certainly, or 2.5 liter. Any experience with lifting heads on LS? I don't think I've run enough boost on stock heads to have that happen yet. But it is a thing with guys that are running really high boost turbo stuff. I'm beginning to experience this issue with an unopened graphite gasket at turbo 5.3. Yeah, if it doesn't have an MLS gasket and it has a stock head on it, it wouldn't surprise me that you would lose a head gasket if you're boosting it. Does the ECU adjust for difference in exhaust systems from the dyno to the in-car exhaust system? The ECU is not going to recognize that you have a different exhaust. All it's going to recognize is that if the power went down because you have an exhaust system in there, then you don't have a mass air meter. You have a fixed curve if you have a Terminator X. So it's supplying a specific amount of fuel in a given RPM and load cell, unless you've changed the load cell with the exhaust, it's going to supply probably more fuel than it needs. What fuel systems are you running on your Turbo LS? But Rod, if you have that in a car, are you running it in a car? Are you going to bring it back in so Ish can look at it on the chassis dyno? What fuel systems are you running on your Turbo LSF? The fuel system that's on the dyno is a big air motive brushless pump. And then we run whatever size injector and fuel rail and stuff that we need. And we also have an air motive fuel pressure regulator that's adjustable. And we just adjust it for static pressure, and then we boost reference it if we want to. Sometimes we don't, but we can boost reference it so that the fuel pressure goes up at a 1-to-1 rate with boost. And then the rest of it, fuel lines or rails or whatever, and injectors, we just put whatever would bolt onto the system that we're running, whatever engine configuration we're running. I need to know. Okay, 219. Okay, so it's a single pattern cam. That's not the camshaft I would recommend on anything. I'd recommend a dual pattern cam. If you already have it, it will work. But 219 is fine for a driver. How far would you push a typical hyper-ejected piston in an NA small block? Well, are you talking about terms of power? Well, we do 1,500 horsepower with a cast piston on a LS. So I don't know about which exactly hyper-ejected piston you're talking about. Richard, have you tested the Daytona sensors ECU? I haven't. We've tested the Daytona sensors. We have their TC1 boost controller, but I don't think I've run their ECU. Rod, if you're going to chassis dyno it, then they'll fix if there's any sort of issue with it. Richard, I saw you on the Fastest Car Show. That's with Chad and his family. Yeah, he did the wagon. When we ran the motor on the engine dyno, it could make as much as 1,000 horsepower. I don't think it had that much when we were running it for that race. And what it had was it didn't have enough traction to do what it needed to do. If our Enforcer had on a stock 302 Windsor versus XE264 HR in stock, I don't know what you mean. Are you asking if a head upgrade will make more than a cam upgrade on a stock motor? Rod, you're not going to have any problem with startup or anything. If the car should start up and drive fine. That will have nothing to do with the exhaust. Joe Nelson, 4-inch Dragon Slayer crank main setted, Oliver rods, diamond. I don't know what the 503 pistons are. I don't know what 2.2 and 2.5 is. Are those the main clearances or something? How far can I push the bottom end? You can push it a long way. If it has a stock, if you have forged internals in it, your next problem is going to be the stock block. Most guys, when they're going above 1,500 horsepower, go to an aftermarket block if you're going to do it for any length of time. The ECU bill is only going to trim fuel if Ish has fuel trims set up in there. If he has targeted air fuel ratios and he has fuel trims set up in there, but I don't know if he did. Is a small base circle cam required for a 6-liter with a 4-inch stroke and a 6/125 rod? No. Instead of the 268 H cam, I would look for a dual pattern cam. Probably something similar for that. Something in the 220 at 50 intake duration, and then it's going to have more exhaust duration. Have you seen results of head upgrade with a higher flowing outperforming a camshaft upgrade? So it would depend on what intake manifold you have. If you have a stock intake manifold, it's going to limit the gains from either one of those. If you have a good intake manifold, the difference would be better, or the difference would be different. The gains would be different. I don't know that a head upgrade is going to show much more than a cam upgrade when it doesn't have a cam. The factory 5-liter has a decent sized camshaft, but I don't ever remember doing a head upgrade first. I have to go back and look through my Ford stuff to see if we ever did that. I don't think we did. I think we almost always put the camshaft in first. I want to spray my 5.3. Do I need to use an 8AN line? Can I use it with a Corvette style filter and not have to worry about restrictions due to the size difference? You're wanting to put nitrous on it and you're talking about changing the fuel line? I don't know what you're asking there. Have you tried the 4-pattern cams? I haven't tested them, but Brule has. And yeah, that's not a thing. You can't cure an intake problem with a camshaft. Is it true the Gen 4 truck intakes are the same as the Trailblazer SS? I don't know. I can't say that universally because I don't know what people mean by Gen 4 trucks. I don't know if some of the Gen 4 trucks also came with what I call the early truck manifold. The Trailblazer SS is distinct looking, and the intakes that look like that perform like that. The truck one looks dramatically different. The early truck one looks dramatically different. So any intake manifold that looks like that is going to perform like that, and the ones that look like Trailblazer SSs are going to perform like that. Vincent, I don't know why you need to change your fuel line for a nitrous setup. Are you talking about the fuel line coming back from the pump? Think about what size the fuel line is going to your fuel solenoid. It's probably a -6. It might even be a -4. And we're going to close out our poll because it's time to get going. We are going to end our poll at 72% saying yes. Steve, yours will be the last question. I got to get going. How can one tell if the intake is limiting power? If you tell me which intake manifold it is, I can tell you if it's limiting it. If you have a stock 5-liter HO intake manifold, it's definitely limiting power. I wouldn't upgrade cylinder heads on a 5-liter before upgrading the camshaft. The camshaft would be the first thing that I would do. Even though it has restrictive heads, on a 5-liter, I would do both. It actually needs all three. It needs an intake, and it needs a camshaft, and it needs cylinder heads. If you want to do it cheaply, put GT40 heads on it and then put a camshaft in it, do springs, and I'd also do an intake. If you're going to get the GT40 heads from an Explorer, get the Explorer intake also and use that. Then that would be a good upgrade. And on that note, it is time to go. Thank you guys all for showing up. I will be back tonight.